like to thank everyone for joining Rumsey on our ongoing Locked In series being hosted by Rumsey specialists. My name is Sean Huber. I'm one of the Automation Systems Group Managers here at Rumsey. Today we're focusing on the power transmission side of our business with a presentation on energy and maintenance savings using polychain carbon belts. So with that, I'd like to introduce David Rowetter and Rick Matzik as the two presenters here today on the power transmission, and they are power transmission specialists. Rick has been with Rumsey for just about 4 years and comes from a background in mechanical design and sits with a seat of SolidWorks in our office that he uses to help design conversions and assists. David's a little bit newer to Rumsey, however, has been in the PT business for many years, and I will let both of them introduce themselves in a little bit better detail. So with that, David, I'll let you take over.
Thank you, Sean. And good morning. Hope this finds everyone safe and sound. We're here today to talk about building an energy efficient and maintenance-free HVAC drive system. And as Sean said, my name is Dave Rowetter. I am one of the power transmission specialists here at Rumsey. I have over 25 years experience selling and applying the PT products and mechanical services. And my counterpart is Rick Matzik. He is our power transmission consulting engineer who brings 25 years experience designing machines and control systems. So that's a little bit about who we are. What we want to do today, our agenda, obviously our little introduction there. We want to go over opportunities for savings. We want to talk about AC motors, synchronous belts, and utilization of VFD'S and how this all comes together and kind of build a savings example through the presentation. So that being said, one of the most significant challenges facing industries today are controlling energy costs. The potential for energy savings through technology grows every day. And I was thinking about that statement, and one of the big things that comes to my mind are all the smart devices that we have out there right now that control just about anything we want to control. So, that's just on the personal side. Why save energy? Well, it saves money, and it also supports green initiatives. Why do we want to save on maintenance? Well, maintenance teams are being tasked to do a heck of a lot more with less as every day goes by. So they're chasing that never-ending, pursuit, if you will, for equipment reliability. So the area I want to focus on today are supply and exhaust air handlers, these big units that are in a lot of commercial buildings, that are in, industrial, pharmaceuticals, 100 horsepower plus units that operate 24/7. There's a significant amount of opportunity for savings on these applications. And I'd like to just kind of walk us through it right now and show you and build this example as we go through. So step number one, obviously we need to build a foundation. A foundation is the most important part of any structure or system, and without a sturdy one, your structure or system will not perform to expectations. That applies to AC motors, and I'm going to show you why here. First off, did you know electric motors are the single biggest consumer of energy? They consume about 2/3 of industrial power and account for about 45% of global power consumption. Let's bring it down to a personal side. Think about your everyday household items, your HVAC units, outside AC compressors, your well pumps, sump pumps, dishwasher, garbage disposals, washer dryers, so forth and so forth. When those cold seasons come in, I should say when the warm season comes in and we need cold in our house, we see a significant energy consumption spike on our electric bill, which means we pay a heck of a lot more money in the summertime for air conditioning. So, we're always looking for ways to save energy. So one of the first things we want to do if we want to look at one of those 100 horsepower units, is verified nameplate information. Is it standard or is it premium energy efficient? You're going to find that a lot of the installed motors out there are still standard efficient, and no one's really touching them because they're running. If it ain't broke, don't fix it, right? But the fact is, you should upgrade it if it's only a standard energy efficient, because there's a lot of different reasons that you can, a lot of different opportunities that you can get. So you might want to, you should consider upgrading. Number one, you're going to capture the energy savings. And number two, you can also capture some utility rebates. I know that the electric companies provide some type of rebate for upgrading to premium motors. So the benefits of upgrading, you get reduced energy losses through improved design. You get reduced motor life cycle costs because energy efficient motors run cooler and they last longer. And they can also be controlled by a VFD, which is going to give us even greater energy savings. So let's take an example here. A 100 horsepower motor operating 24/7 with an electricity cost of 10 cents a kilowatt hour. Have any idea what the operating cost of this guy would be? Why don't you guys write something down if you have a paper and pencil? Just write a number down, see how close you come. Here we go. On a standard efficient motor, which is 93.6% efficient, $67,000 a year it costs to run that motor. We upgrade to a premium efficient motor at 95.4%. It costs $66,000. We get about a $1,271 annual savings by upgrading to a premium efficient motor. Doesn't seem like much, but with the premium efficient motor, now you're able to do some additional things with it. And as we go along, I'll explain that a little bit more. So once again, we'll take a recap here. 100 horsepower motor, 24/7, 10 cents a kilowatt hour. Upgrading the motor only, you got an annual energy savings of $1,271. That's why we want to look at motors. We want to upgrade whenever we can. Number two, so now we want to continue to build this HVAC system. Throughout industry, there's one thing in common. There's belt-driven fans. A significant amount of energy and maintenance savings could be realized by improving efficiency and reliability of these applications. Did you know, according to the U.S. Department of Energy, energy savings in switching from a V-belt to a synchronous belt drive system is at least 5%. This piece right here, and I posted this, and we can supply this to you. This piece is what we base all of our savings off of. The savings can be a significantly amount more, but we're going to base everything off of 5% because this is what the U.S. Department of Energy says that could be realized. V-belts versus sync belts. Majority of today's belt drives use conventional V-belts that, when properly tensioned, are wedged into shivs and generate friction to transmit the load. So a newly installed V-belt is approximately 93% efficient. However, V-belts elongate, we all know that, and require retensioning on a regular basis. A poorly maintained or floppy belt drive can reduce efficiency by over 10%. This is what they call speed loss, which wastes energy. There's another interesting factor here too, and it's called belt creep. So a properly tensioned V-belt will be 93% efficient. If you took a strobe light and you put it against a V-belt and a shiv as an example, you'd be able to stop that shiv dead in its track with a strobe light. But if you put that same strobe light on the label of a V-belt, you're not going to be able to stop that belt. It's going to creep along and creep along. And that is what they call belt creep, and that is wasted energy. Synchronous belts, they virtually do not stretch, and they remain 98% efficient for their life. So this reduces energy consumption, and it also reduces the need for maintenance. Just a kind of a comparison, a friction drive. You see the sidewalls of the V-belt that gets wedged down into the sidewalls, if you will, of the sheave, generates friction, drives the fan. As that belt stretches, that friction becomes less and less, which means the belt slip, so forth and so forth. On the right-hand side, we have the positive drive, which is the synchronous belt. That's a tooth engagement. It's 98% efficient for the life of the belt. There's no slip. I'm going to hand it over to Rick right now, and he's going to go through a couple slides to show some comparisons.
Good morning, everyone. What we're going to talk about is just the technical side of how we go through the process of checking the size of an existing V-belt setup and also replacing it with a synchronous belt setup. If you look at the screenshots here we have on the presentation, you can see the default service factor that we use for sizing V-belts is 1.2, which means, let's say in a typical 100 horsepower situation, which is what we're showing here. It's the example that we're showing. You're looking at a belt that's rated for 120 horsepower, and that's what is normally done. The service factor on a V-belt is generally less than what's on a synchronous belt because V-belts kind of tend to have a built-in torque overload where they will slip and not cause overloads on your motor. A couple things to point your attention to is the center distance of the V-belt, and that's one of the things we try to match up to when we design for the synchronous belt, because there's not an infinite numbers of sizes of belts. You have specific ranges that you need. You have to match up the sprockets and the belts just right to fit the center distance properly. Another thing to point your attention to is for a 100 horsepower application, you're looking at 4 strands of V-belts, and this is the Super HC style belt. So these are a little bit tougher than a standard V-belt that you might see out there. Those might be less, let's say, less highly rated than this particular one. And the width of the V-belt setup, because it's 4 V-belts in a row, it's about 3 inches wide. You could go to the next slide, David. Dave, can you hit the next slide, please?
We run it. There you go.
There it is. Okay. We did not have technical difficulties. As you see here in the screenshot, we're showing that we're looking at a 1.6 service for the synchronous belts. And that is because they do not have any kind of built-in overload and slip. So whatever the application requires, they're gonna draw it. They would either break or they would or drive it. If you look here, what you'll see is that a belt that is much smaller, almost half the size, you're looking at a rated horsepower of 237 horsepower. Again, our design power for this for a 100 horsepower unit is 160 horsepower with that 1.6 service factor. The closest belt to that result is rated for much, much higher than what that 4V belt setup is, and you're saving space. Also, what you'll see here is based on what the criteria for the center distance, because you don't want to have to change your whole installation to accommodate this upgrade. We will look through the software, and the software actually gives you multiple setups. We pick the setup that is closest, that falls within the install and take-up range of the existing belt. We do that for you guys. Another thing that we will do is we will also check out spatially and how the new belt setup will fit. Dave, if you want to get to the next slide, please. We actually will download the solid models for all of these components. Go for it, Dave. We'll download the solid models for all these components, and we'll do a little check on all the physical constraints just to make sure everything is going to fit properly. As you see here, this is a little video that we put together to show the actual installation of a new belt. And you can see you're saving a lot of space. we were able to hit these center distances for the motor to make sure that you didn't have to move anything else, that the existing adjustable motor base would actually work with the new belt setup. And it kind of helps, you guys know that what you're getting is really going to work for your system and your setup. And you will know exactly what the new horsepower rating and how well designed your new setup will be compared to your old design. That's all I have, Dave.
Okay, thank you, Rick.
Thank you.
So let me make sure. So efficient drives equals energy savings. So a little formula here is what we use to calculate the kilowatt hour saved by switching to a synchronous belt. Excuse me. And it's a fairly straightforward calculation. Maintenance. V-belts and synchronous belts take about the same amount of time to install. The maintenance savings realized by upgrading to a synchronous belt platform. A few things here. Can eliminate nuisance retentioning of V-belts. You can eliminate quarterly replacement of V-belts. Can increase your uptime. The synchronous belts last longer than conventional V-belts. So with maintenance departments being tasked, to do more with less, it's a great option here. So let's get back to our savings example. So we have this 100 horsepower motor, 24/7, 10 cents a kilowatt hour. So we upgraded the motor. We're going to save $1,271. Now what we're going to do, we're going to upgrade the motor and we're going to upgrade the V-belt drive to a sync drive. Now all of a sudden we're at $4,644 a year in savings. That's electrical savings. Plus we can get another $300 per year on maintenance savings. And that's basically, that's driven by one employee at $100 per hour, fully loaded price, times 3 eliminated inspections and retentions per year. Most likely you have 2 people doing this job, so that would actually go to $600, but we'll keep this conservative here. So we have an additional $300 of maintenance a year, which gives us now, of energy and maintenance savings so far of $4,944. Not a bad thing, and that's year over year over year. Kind of giving you an idea of efficiency comparisons. Right here, this 93.6 and the 95.4%, with the 5% increased efficiency. Like we said, we're looking at $4,944 a year. If this V-belt would stretch, and start flopping in the wind, if you will, it could be as much as 10% inefficient. Your savings would go up exponentially here to, $8,700 a year. That's just kind of giving you an idea of how much wasted electricity there is. So as Rick pointed out in the video, this is what a successful upgrade would look like. You have your V-belt drive, which you can see how wide that is, and you can upgrade that with the same horsepower or better synchronous belt drive, and it's a lot narrower, it's more lightweight. It's just a better drive all the way around. So our third step, we want to finish the build. Our third step is utilizing the VFD. Did you know? Today's VFDs are affordable, they're reliable, have flexible control, and offer significant electrical energy savings. This is all accomplished through affinity laws, and I'll try to get through this as unscathed as possible. Energy consumption in centrifugal applications follow the affinity laws. Flow is proportional to speed, and horsepower is proportional to the cube of speed. I'm going to take that last statement. That means if a motor running a fan operates at 95% of rated speed, it only requires 85% of rated power. I'm going to probably toggle back to this in a minute, but I'm going to move forward. Here's a V-belt application, the 100 horsepower V-belt application that we've been talking about. So we have 100 horsepower, 1750 at 60 hertz. That's our theoretical sync motor speed, right? So we have a 2-to-1 V-belt drive on there. Our theoretical fan speed should be 875 RPMs. But remember, a newly installed V-belt is approximately 93% efficient. That effectively reduces the fan speed to 831 RPMs. As the belt creeps and stretches and the shivs wear, our fan speed is going to continue to decrease. This is all loss of energy. So let's remember those numbers. So basically, we're going to be at 831 RPMs effectively. Let's look at a sync belt. 100 horsepower, 1750 at 60 hertz. 2-to-1 synchronous belt drive, right? So our actual, not theoretical, our actual fan speed should be 875 RPMs. This is where the affinity laws come in. So if your airflow was sufficient and your system was balanced, utilizing the original properly tensioned V-belt drive, remember, 93% efficient, you can reduce your hertz on your VFD by 5% or to 57 hertz and achieve the same fan speed of 831 RPMs and maintain the airflow for the life of the synchronous belt. Remember, flow is proportional to speed. Plus, we're going to get a 15% energy savings. Once again, another affinity law. Horsepower is proportional to the cube of speed. So there are the two big things that come out of this. And you say, well, what do you mean turn down my VFD? Well, once again, flow is proportional to speed. So if your flow was X, that was based on speed of the fan. So if we match those two, there's a heck of a lot of energy savings to be realized here. So let's bring it together here. So we're going to upgrade to a premium energy efficient motor. It's rated for VFD use. We want to upgrade to a sync belt drive. We're going to be 5% more efficient. And we want to utilize a VFD. We want to take advantage of those affinity laws. That's where the energy savings live. Here's our savings example again. So our 100 horsepower motor, 24/7, 10 cents a kilowatt. We're down to $4,944. If we follow the affinity laws and we reduce our hertz on our VFD by 5%, our total savings on one system is $14,449 a year. That's substantial. And if you have 10 of these units in your facility, that's a lot of money that you can save. So there it is. We just built an energy efficient and maintenance free, if you will, HVAC belt drive system. We got current savings of $14,449. That's one, like I say, one 100 horsepower fan application. So if you are looking to upgrade and you're interested about this, let us know. What we can do, like Rick was saying earlier, we'll come out and we'll perform an on-site survey. We'll inspect the system, we'll do all the measurements, know exactly what you have. There's some other things you need to look at too in terms of motor bases and making sure that they're suitable for the application. We develop those V-belt drive analysis like Rick showed you, and then we'll develop that synchronous belt analysis like Rick showed you. And we do that so that we can show you on paper that these will properly fit and they will properly function. We can also provide an energy savings, a payback analysis, and carbon footprint reduction estimates. That's all comes up as a service here. So they're the things that we can do here with synchronous belt drives when it comes to fan applications. There's a lot more you can do with them, but we're just going to stay focused on fans right now. And if there's any opportunities you're looking to upgrade, we would welcome the opportunity to come out and do a survey. Obviously, once all these restrictions are lifted. But yeah, we definitely love to come out and work with you and show you what we can do and show you what kind of money can be saved.
Hey Dave, a question that comes up an awful lot around sheaves themselves. What's typical in industry as far as replacement of the iron, timing wise?
The iron, the manufacturers will tell you that the iron should be replaced after every third belt change. So on a V belt. So if you are at a point where you're ready to change the iron because you're at that life cycle, now is the ultimate time to invest into the synchronous belt drive, because you're going to be investing into the iron anyway for your V belts. So it's a great opportunity to do that upgrade. Even if you just went with a belt drive, you're getting a lot of the control over your fan. And if you do have a V8, well, you need it all. In order to make it work properly, you need that premium energy efficient motor. So if that's already in place, that's a great thing, right? So yeah, if your iron on your shivs, if you will, are at that point of needing to be replaced, replace them with a synchronous belt application.
All right. Well, with that, if there's no other questions, I will we'll end the call here. So I guess I just want to say thanks for tuning in today. We will continue through the month of May, every Tuesday and Thursday, having something associated to a technical topic. If you have any questions, feel free to reach out to any of the specialists at Rumsey or the sales representatives at Rumsey. So with that, I appreciate it and have a great day.